Hey everybody, welcome back to the Project Euler archive series. Today we're taking a look at problem 3 called largest prime factor. So the prime factors of 13, 195 are 5, 7, 13, and 29. What is the largest prime factor of this number? So before we start dealing with prime factors, we just need a basic is prime function to determine whether a number is prime or not. So let's write that here. Of course, there are many ways to implement this is prime function. I'm just going to implement the naive solution because there's no time limit on Project Euler, and that's the easiest to do. So is prime, we'll take in n, and then we'll just loop through all of the numbers from 2 up until the square root of n and see if it's a factor. So I will need for I in a range from 2 up until, we want to go from 2 up until the square root of n, but this has to be an integer, so we'll floor that. And then we want that inclusive, so we'll add a 1. Okay? And then if n mod I equals 0, that means it has a factor, so it's not prime. And if the loop completes without that condition being true, then we return true. Okay. Cool. I think that should work. And now we need to just write the rest of this part to see what the largest prime factor of a number is. So let's see if we can just write some code to figure out what the largest prime factor of num is right here. So we should get 29. So what we can do is if we loop through all of the numbers from 2, again, this is not the, I know this isn't the most efficient way to do this, but it's the easiest way to do it. If we loop through all the numbers from 2 up until the square root of n, and we see if that number is a factor of n, we'll get back 2 numbers. So like here, for example, if we have num and we realize that num mod I equals 0, that means that num equals I times some number a. There, we just if this condition is ever true, that means we just discovered 2 factors of num, and then we'll check if both of them, if either of them are prime, and we'll just keep track of the largest prime number. So largest prime, I'll just say largest equals -1 for now. So we know that the next number we get will be bigger than largest. And then for I in a range, it's going to be this exact same thing. Actually, we want to go up to the square root of num inclusive. So for I in range 2 to the square root of num, we'll see if num mod I equals 0, okay, then we have I, and then we also need a. So a would be num divided by I. And then if is prime, so if I is prime, then largest equals max of I or largest. Yeah, so for example, let's say we are at some point and largest is 13, and then we come across I, which is 29. Largest will be the max of either largest or I. And then if is prime of A, largest equals max of A largest. Okay, let's see if this works on our test case. So we should get 29. Great, we got 29. So let's see if it works for this number. Just gonna make this num like that. Okay, we got 6857. Let's see. 6857. Solve problem number 3. Just got this award, Baby Steps, because we solved the first 3 problems on Project Euler. I'll see you in the next video.